King's College of Engineering, Tanjavur, Tamil Nadu in the year of 2014. Later, he was promoted as associate professor in the year of 2016. Currently, he is working as professor in the Department of Mechanical Engineering at Narasimha Reddy Engineering College, Hyderabad. He has published around 15 research papers in the reputed international journals, owns 2 patents, and also has presented many research papers in international conferences. He has organized more than 30 programs and has attended more than 15 conferences, 20 workshops and faculty development programs, and has been a reviewer for more than 7 international journals as on date. He is an active member of ISTE, ISME, ISRD, IAENG, IRED, ASHRAE, and IASTER professional societies. He has exhibited his leadership skills by being NSS Captain, Secretary of Humanities and Science Association, Secretary of Mechanical Engineering Students Association, President for the Alumni and NSS Faculty Coordinator at CSI Engineering College. Dr. M. Babu sir, who is an expert in all aspects, has accepted our invitation in spite of his busy schedule to enlighten us with his knowledge and experience about nanosensor. So with these few words, I would like to hand over the session to the resource person. Sir, Dr. Babu sir.
Sure. Thank you very much for the introduction.
Sir, please, sir.
Good morning,
Welcome,
one and all.
Good morning, sir.
I welcome you all for this FTP. It's my pleasure to be a part of this, and I thank the head of department, the principal, the management of Gnanamani College of Technology for giving me an opportunity to do this. So I'll start with my presentation. And so good morning, one and all. I'm Professor M. Babu, working as a professor at the Department of Mechanical Engineering, Narasimha Reddy Engineering College, Hyderabad. As Sir told, my research area, as Sir introduced me, my research area is actually into thermal field. And I worked with a solar system called the linear Fresnel reflector system. So how come I got little into sensors is the problem which I faced during my research. Actually, I'm not into nanosensors. When my total setup was fabricated and I went for the experimental analysis, performance analysis, so I had a lot of issues in keeping the system perpendicular to the sun. So as all we know, being mechanical engineering, to take the maximum sunlight given out by the sun, we have to track the system in a proper way. So there I went with around 50 or more reputed journals, which I took the literature review and went with those type of tracking, because normally tracking when we go with embedded and sensors and things, too much of electronics is also required there. So started studying little. Luckily, we studied little when we were doing our mechanical engineering. We studied little microprocessor, a little with mechatronics, little with robotics. So where all this electronics is mingled. And even if it is an electronic device, the device is manufactured by us. And the device, most of the devices are used in the mechanical stream. So that is one reason I started learning a little more about sensors. And the main problem was, even though if I went with a lot of literatures, which gave me some details about tracking the solar system, because my main objective on my PhD was not on tracking. It was on designing of the system, material study and performance analysis based with thermal history. So the performance of the system is totally based upon the light which is going to be received by the system. So anyhow, it was like when I started with theoretical and analysis, we manually tracked and we assumed that it has zero error tracking, no tracking error. So everything is fine. So, but when experimental, practically when we came, I faced a lot of problems. So then started studying, and it was a bit difficult to find the proper sensor. So then little by little, took around nearing around 2 years to find the system to track well. So it was there I learned a little about sensor, because sensor field is a very vast field and very upcoming field, because nowadays without sensor we don't have anything. We know that. So now coming to the next part, uh, here the topic given to me is related to nanosensor. Anyway, I'll just go with nanotechnology a little bit, and we'll enter there. So now coming into nano, when we hear the word nano, immediately in our mind we get a structure. What is nano? Is it a structure we get immediately? No, actually, to be frank, when we start studying about nanosensors, nanotechnology, we get it. Then what we get normally when we tell nano, do we get the structures? No. Being in India, I'm damn sure that, including all people, when when we tell the word called nano, the immediate thing which comes in mind is Tata Nano only. So just talking about here, the difference between Tata Nano and our nano technology is totally different, but the size matters. Tata is a wonderful person, Mr. Ratan Tata, a legend of India. We should always appreciate him, being especially a mechanical engineer. We should be proud to have a person like that who did a lot to the country. And he was the person who introduced a car called Nano. And people started understanding that nano means, what is nano means? It is small. But Tata gave it in cheaper price, but our nanotechnology is not so cheap as Tata Nano. Our nanotechnology is coming up, little expensive, but very interesting area. And maybe in future, like how people tell a robo is going to rule the world, like that, nanotechnology is going to rule everywhere. So what is nano actually? A billionth part of meter. So a billionth part of meter is called nano, and the symbol is small n. So prefix meaning is 1 billionth is a nano. Next, for example, to understand better, I've taken this. A sheet of paper is about 1 lakh nanometers thick. So regularly, we are using a sheet of paper to do a lot of things. So it will be easy for us. And next thing, they compare with our air. When you cut your air, the diameter is also around 1 lakh nanometer thick. So these are where we can imagine what is going to be the size of the nano particle. So nanometer is a measure of length whose symbol is small nm. It is a unit equivalent to 1 billionth of meter. Nanoparticle is a main thing which is supporting the nanotechnology. So when we talk about nano sensor or nanotechnology, everywhere the particle matters. And here where even if the application of nano sensor or nanotechnology is used in various fields, the particles and things, materials, everything belongs with the stream of materials, manufacturing, production. And nowadays we know very clearly that any technology, even if you want to manufacture a car, normally we tell automobile engineering. But in today's life, a car has to be supported with a computer science engineer, which is automated, a program has to be done, an embedded system, electronic engineer, batteries, electrical engineer, totally the mechanical engineer, the design, man, everything. So we normally call it as interdisciplinary engineering. So now, olden days, we used to tell students that they study interdisciplinary, but nowadays, even all the products have become interdisciplinary. Olden days, the very first machine used was lathe. Now we call it a CNC. Without an electronic device, electrical current, or a program, we cannot do that. So everything cannot be done by an individual person. It's a bit difficult. We all know what is engineering. Even in our own stream, we have different areas. So we select some particular area and we try to be little good at that, take more exposure in that, learn things. Because normally being in teaching, I always feel that we are always a student. It is not only teachers should be a student. Each and every person in the world is a student, including parent or whoever it is. We know that. So nanoparticle is a very good area where a lot of research can be done. Because when now commonly talking about faculty development program, very few senior professors, associate professors, or doctorates who have completed doctorates will be there. Some people, they may just want to know something about that area. And if okay, they can interdiscipline with their research and they can do something. That is one reason they come. And many young faculty members who join here in faculty development program, the main thing is to develop yourself not only in that particular area, it is about to develop yourself in your research and parts. So whenever we go through this, even this FDP, which started today, so this area, the sensor technology, the nanoparticles, and the resource person who I saw all are very good. So maybe I am the winner of all this. So you'll be getting a lot of details. So whenever you go through that, even if it is basics or wherever it is, our mind should be open to take where I am going to do something in this area. So which will help you a lot, especially for the upcoming faculty member, young faculty member who are very much interested in research. Because normally in our area, what happened is, since I'm in teaching, sir, I have to get a doctorate. I have to get to survey. It's not like that. And it is that our interest. And since I started this, actually I wanted to tell in the first slide, but anyhow, I thought when I come into the coming up faculty and engineers, I wanted to tell this. Today's presentation, I dedicate it to Dr. APJ Abdul Kalam. His birthday, I think you all remember. When is his birthday? It's 15th October. So the month of October, we have started this. So I dedicate to him. And I used to think about him a lot. A person who was born in Ramanathapuram and he has become a president of India, and a very special personality who always gives wonderful proverbs. So when I was thinking about this, I got one thing in my mind. I just wanted to share it. If I'm like giving this lines for Dr. APJ, sir, even I did not think I will become president of India when he was 20 years or when he became an engineer. Do we all believe this? Yes, we have to. Even Dr. APJ sir would have not thought that he'll become president of India. He started his engineering in MIT in 1960, I hope. Then after completing, he joined DRDO. Today I am at Hyderabad. You all people know DRDO, DRDL is there in Hyderabad. Even my batchmate is working. That DRDL is being brought into Hyderabad, and which was done was only because of Dr. APJ, and who contributed a lot in engineering. And also, to be frank, many of the engineering students got the belief that they can do something. So I dedicate this for him. So now I'll go into this. Thank you for understanding this, because I'm a fan of him. So Coming here, a nanoparticle. So it is ultra fine unit with a dimension measured in nm. So 1 nanometer is equal to 10 power minus 9 meter. It's approximately 0.091. So nanoparticles exist in natural world and are also created as a result of human activities because of their submicroscopic size. They have unique material characteristics and manufactured nanoparticles we find practical. Application in variety areas including medicine, engineering, catalyst and environmental remediation. So, for example, they tell atom is 0.1 nanometer, DNA is 2 nanometer, human hair is 1 lakh nanometer with, as I discussed, like our sheet of paper, same. This is for something to understand. 4 feet tall is 1.2 into 10 power 9 nanometer tall. Empire State Building is 3.81 into 10 power 11 nanometer tall. So, nanotechnology. So whenever we talk about technology and things, it is always better to remember the person who gave us. So he's called the father of nanotechnology. Yes. Am I okay? So Mr. Father, sir, can you mute it? So Richard Heman, the father of nanotechnology, nanoscience technology, a study of application of extremely small things that can be used across the science fields such as chemistry, biology, physics, material science, and engineering. So he was the person who brought us the nanotechnology. So always it is good to remember Richard. And next, Laurel, Nobel Laurel Strong. So when normally people used to ask, sir, what is going to be the development of this field? If I'm going to do something in this, if I want to do my research, I want to do something, what is going to be? So he is clearly telling that nanotechnology, he's a physics scientist. Nanotechnology has given us the tool to play with an ultimate toy box for nature, atoms and molecules. Everything is made from it. The possibilities to create new things appear limitless. So as I told you, everywhere there is a scope of nanotechnology. Even if we go with a different type of research, where nowadays we bring with nanotechnology. So coming into this next application of nanotechnology, which includes titanium dioxide, which is used in sunscreen. So normally zinc is also used. So even a very good example, which actually interesting, is the nanotechnology. In some case, even we use in our kitchen, the chili powder which you crush, the masala powders which you crush, everything is almost the basic of nanotechnology, which mixes with the curry to eat with. Minute parts. And the same, the materials which are used in sunscreen is all nanoparticles, which provide or save you from ultraviolet radiations. So normally when we talk, there are UVA and UVB. So UVB is the sunburn ultraviolet ray. So this nanotechnology, which is given in the sunscreen, it protects your face. Even in that, interesting thing is we call one factor called SPF. It is called sun protection factor. So that should also not exceed. That is why when we talk about creams and cosmetics, they tell which is better quality. We check that. So everything has to be in a proper pH and things. So approximately 30 to 50 SPF is given in the sunscreen. So that all are nanoparticles, which is used there. One is for giving color. One is for sunscreen like zinc oxide, which is used as a sunscreen. Titanium oxide to give a clear and clear the skin. Titanium oxide is used there. So next, in food products, we use a lot. Silver nanoparticles in food packing, clothing, disinfectants, and household appliances, such as silver nano is used. Carbon nanotubes are used for stain resistance, textiles, resistance, and things. Sodium oxide for fuel catalysts, they use it. So like this, each and every day, it's little more development is there. So when we talk about this problem with this nanoparticle is the cost involved in that. So there is a lot of scope in material research for nanotechnology. Nowadays, many people are doing very good research in materials. So in that also we have selectively doing in composites, alloys and things. We have alloys in nanoparticle also. But coming here, we can try with some materials or preparation of nanoparticles. And I want to put a word, if somebody is interested in future, if you are doing something related to nanotechnology, my guide, Dr. A. Valanarasan, is a professor at the Department of Mechanical Engineering, Tyagaraja College of Engineering. He is in charge for the nanotechnology lab, which he got through DST, project through DST. So I can request him to help you also, because the problem with the nanotechnology is the facilities normally, which we don't have in many institutions. We have very few in some reputed institutions. So in that stream also, in future, you can contact the coordinators so that if any need, I can help. Or even directly, if you people are interested, you can take permission from the college at Tyagaraja College, Madurai, so that you can request and you can use the lab. There are many research people doing there. Full-time scholars are there. I think 5-6 full-time scholars are there who are working in this nanotechnology. So I visited there, a nice lab. You can also go there. So next, coming under applications, because I just wanted to tell why, because directly when we go to sensor, what is the use of it? So we should know the technology before applications where we go. So nanotechnology in medicine plays a very big role, especially what we talk, the nanosensors plays a very big role in nanotechnology. Normally it is called as nanobiosensor. And so now, olden days, if any problem is there, it has to be cut and operated. Now you can just insert a nano cable with a nanosensor, which goes, studies your body, finds the block, angiogram, all well-known things which nowadays is going on. So even now, we get little difficulties. It is a technology comparatively going good, but still there are some small limitations which has to be removed, because when we talk about human body and things, certain things has to be taken more care. So still research, very big research is going on. So coming under medicine, medical use, nanomaterials, drug delivery, we use cancer, very wonderful performance, which is done by nano, which is curing cancer. And the chemotherapy is nanoparticles. Surgery, tissue engineering, visualization. So there's all some applications. Nanotechnology in electronics, allowing more transistors to be packed in a single chip, allows higher electron mobility, the higher electric constant, faster frequency is there, and single electron transistors can be manufactured using electrode made from nanowires, using nano-sized magnetic rings. So because nowadays we know the electronic goods, what we buy, day by day it is getting slim, day by day it is getting more clearful. Everything is behind this technology called nanotechnology. So nanotechnology in computers, computer processors, more powerful, ultra high density memory. Silicon transistors are replaced by transistors based on carbon nanotubes. The carbon nanotubes is a wonderful area. Size of microprocessors reduced to greater extent, and numerous materials as a future replacement of flash memory. Sir, is my audio and all clear? Is there any issue?
No, sir.
Sir, clear, sir.
Okay, thank you. Okay, thank you. I'll just check in between so that sometime we should not miss with improper communication. That is the reason I'm just checking in between. Thank you. So next, coming into energy. Nanotechnology, as I told you, it is not living any field. Nanotechnology is very perfect with all the field. Creating device smaller than 100 nanometers give us new way to capture, store, and transfer energy. So storage, where very big demand is there, that also now nanotechnology started playing a role. Even I was very much interested when I was going through nanotechnology and studying. I thought we have to plan for the storage system. Next, increased efficiency of lighting and heating, increased electrical storage capacity, a decrease in amount of pollution from the use of energy. So these are some applications on energy. And sports, reducing the rate of which air leakage from tennis balls, so they keep their bounce longer. Such a small things also it is, because normally when we think about engineering, we think about big things. A small thing can also give us a very big results. So in sports also we use it. So golf ball to fly straighter, bowling balls become more durable and have a harder surface. Food, nanotechnology is having impact from how food is grown to how it is packed. And companies are developing nanomaterials that will make a difference not only in the taste of food but also in safety. Because one more interesting stuff here is since we are talking about food, these nano particles, for example, if you take any tube like or bottle, shampoo bottle, or toothpaste, everything, when we use it after the end, still we have a toothpaste left inside. If you take a shampoo bottle, you have shampoo bottle. Normally what we do, we put water and use it. If the mouth cannot be opened, that shampoo is thrown only, the toothpaste is thrown outside. Like this, when you take even some food products, a sauce bottle, you have to shake it, you have to bring it out. So here now they are planning for giving internal food safe nano coating for all materials, where we should not use where we should not waste food products. That is an interesting research which it is going on. Since we are much into food product, so they need a very good material which can be coated internally to the container, so that once you just put it up to the last drop, it won't stick inside, it will be coming out. So that is a very good area where present development is going on, and already I think few companies have started. But since it is related to food, they want to check for the toxic and things. So, and also it should not spoil the taste. So every than taste toxic or poisonous things should be considered more. So when we talk about any material, normally people used to tell, don't keep food in plastic, don't keep food in plastic, don't boil. The reason is the toxic. So like the same when we talk about the food and things, material research is a very good area. The zinc oxide nanoparticles can be incorporated into plastic packing to block UV rays and provide antibacterial protection. So improved strength and stability of plastic packing, so where this nanotechnology is used. So these are that wide applications, and also nanotechnology much used in telecom, in defense, agriculture, information technology, medical and pharmaceutical companies, in material research, in automobile, in energy, aerospace. So these are few. As I told you, it's going to be everywhere in few days. Even now, in plantation, they are planning for nanotechnology. So applications in the field of mechanical engineering, especially we talk, it is very much used in biomedical and engineering, fluid mechanics. We know everywhere in heat exchanging areas nowadays we require fluid mechanics. So normally we call it as micro channels, micro cooling. Now it is coming into nano cooling. So I remember some of my friends who did heat transfer analysis and PhD in uh, microchannel heat exchangers, where they used nanofluids. So it was easy to prepare. Like what the combination, what they did was like using some liquid mixing nanoparticles, that is the powder, potassium or some powders, which is good at flow and fluid. So because when you go into fluid mechanics, there should be a proper flow. Viscosity should be maintained. So this the parameters considering they did. So it is also an area where a lot of research is going on because cooling is very important nowadays. So there nowadays we know we are using a lot of micro products. So it has to be cooled. There nanotechnology is coming up. Combustion and the environment, ground vehicle system, heat transfer thermodynamics and energy system, manufacturing, mechanical design, system dynamics and control, transportation system. So everywhere it is being application of nanomaterials, next generation computer chips, kinetic energy penetration into improved quality, better insulation materials, prosperous of high definition TV, low cost flat panel display, tougher and harder cutting tools, and the elimination of pollutants. So these are where the nano materials are used. So this, they compare what is the size of nano. Normally, when we enter into this, so DNA is approximately 2 to 12 nanometer diameter, and the carbon nanotube is 2 nanometer diameter. So that is the size difference. And if you check our red blood cells, it is around 50 mm. So the difference here, even a single red blood cell, if it is having some issue, and if we are able to treat it with the nanotechnology, we can do it. Nanotechnology, the general history, 2000 years ago, the first person, a Greek person who dyed air using the technology in 1000 gold nanoparticles, different colors of glass windows were done, 1959. So the development, I don't want to read all. So from 1991, like 2000 years ago, they started a little bit. Now, approximately after 1991, up to carbon nanotubes, we have come, and the further development rapidly going on. So the thing is, even before 2000 years ago, when they started, the research didn't stop. Further development, the father who did during the year 1959, physics scientist, told you, Richard Feynman. So he's the father, normally we call him, he's the father of nanotechnology. So after the development is coming very good. So there are lots of scope where you can do much research. So nanotechnology, other average thing which you can tell generally is the field of research, innovation concerned with building things, generally materials and device on the scale of atoms and molecules. So a nanometer is 1 billionth of meter, 10 times diameter of a hydrogen atom. The diameter of human hair is an average of 80,000 nanometers. So this is the scale classification of atom and a nano material. So carbon nanomaterial, which is around 1 nanometer, and atom is a 0.1 nanometer. So once we want to manufacture a 1 nanometer material, so we can use atoms to mix it together to produce it, atoms of different material. So general structure, whenever we talk about nanometer, nowadays when we see round color structure, we are a little afraid, thinking corona, just like that. So what is nanotechnology? So interesting stuff nowadays, which is happening. We used to see in movies and all. So such a small technology, even which you can make a fly, the structure of a mosquito, a honeybee. So these all is the interesting stuff which is used. Nanotechnology, shorter nanotech, is understanding and control of matter at dimensions of roughly 1 to 100 nanometers. So maximum it is up to 1 to 100 nanometers. The nanometer is 1 billionth of meter, the width of 3 or 4 atoms. The metric way when we check. So milli, micro, nano, and pico. So this is the metric system which is given the measurement. So milli is 0.001, meter, micro is 0.5 zeros, so nano is 9, and pico is 12. So coming here, micro, and nano. So these are the difference in the last pieces of nanotechnology. So here they have compared it with the bacteria, ant, bacteria, and nano. So you can see the nano values of it. So a bacteria is 2000 nanometer, carbon nanotube is 1.3 nanometer. So the difference is like that. Normally we know that when seeing a bacteria through our eyes is very difficult. So just think about this nanoparticle. So structure of nanomaterials. Normally I think tomorrow Jaivel sir will be discussing a lot about this. So I'm just giving a single slide. So OD, 1D, 2D, 3D, bulk structure. Hello. So the direction axis, which is steady. So OD is the nanoparticles. So photocatalyst activities that we can do. So next 1D is rods, wires, tubes, waveguides. The 2D is nanofilm, nano coating in PCs and mobiles which we use. 3D is nano composite, which is used in all applications. So this is the size and shape structure of nanomaterial. Next, coming into sensor. So nanotechnology is a part which we have just seen a basic of it. There is a lot if you want, you can study. So sensor, as I told you, it's a device which almost acts as an input, which gives the input to the system which you have to operate or make the system to work. For example, if you take very well known as a robo, the robo normally all input is given with sensors. So the sensor gives the signal to the controller, which we call normally as a brain. So that controller is fed with program. So you have a feedback attached. So if the sensor is not proper, automatically the total system is not going to be proper. So that is a very important thing in sensors. Because nowadays, each and every device which you use, it's all with sensors only. The sensors are not perfect. And one more thing, the sensors has to be with a better material depending upon the application and a better size depending upon the application. So this is the reason where the sensors were developed and brought into nanosensors. So sensor technology, we know, within a nanotechnology field, there are many subcategories. One of which is being nanosensor. To comprehend nanosensor is you must first understand the purpose of a sensor. A sensor is a device that detects a movement and responds to recording it and conveying it to another electronic device. So the data which is read by the sensor as input, it has to process it and it has to respond to it. It has to detect it. It has to respond to it. It has to record it and it has to convey the same to the other device which it has to supply. So these are the main requirement of the sensor. So, and we also know that there are different types of sensors. So in every sensor now nanotechnology is implemented and they're doing a lot of research. So when we talk about the sensors, so what is inside the sensors is materials. So the development change in material will give you a better sensor. Development change in material with the nanotechnology gives a better nanosensor. And nowadays the nanosensors and things are a little bit expensive. A lot of research they are trying to go with a better material change. The sensors can be classified either based on signal production or by different methods they employ for signal transduction. So transduction can be placed through a number of approaches. There are presently three main transduction approach categories based on detection mechanism: electrochemical detection, optical detection, and acoustic mechanical detection. So this is the common principle of sensor. So definition of sensor is a device comprising recognizing element, transduction element, and signal processing capable of continuously and reversibly reporting the chemical or physical information. So example, our body. If you pinch or if you do anything, you get the sense, goes to the brain. Like the same here, there is a transducer, a sensing element with a transducer which senses. The signal is given as analog and goes to the computer, and you can see what is the process happening there. So coming into nanosensor. Nanosensors are essentially the result of combining nanotechnology with sensors. The nanosensor can be defined as a device that communicates information about the behavior of particles at a nanoscale level to the microscopic level, where it is visible to the naked eye. So that is the advantage here. So nanoscale level, it can be converted into a microscopic level, or again with a bigger screen, you can go with the technology is like that. Just like how we use a microscope and read. So using nano, you can convert it into micros. So the advantages are a lot. So nano chips and nano things which we see, they've shown a chip there even because normally people know one more thing in nano is SIM, like nano car. Many people they know one more thing is nano SIM. So many cases before nano SIM came, mobile phone came. So we have to take the micro SIM and cut it into nano SIM. So nanosensors, the nanosensor is an improvement in sensor technology, which is based on the use of structure provided by recent advance in nanotechnology, such as nanowires, nanotubes, and nanoprobes. So when nanotechnology started growing up, as I told you, other devices started. So in that, one is your small, very small part. Nanotechnology is your nanosensor. So approximately, like you can see the pic of different nanosensors which are used for different application. Okay, what is the need of nanosensor? We know that very small things we have to do, but what is it? So compared to conventional sensor that are commonly used right now, nanosensor are far superior because of many reasons. To name few, I have given something down. Nanosensors are significantly smaller, making them more portable. That is one advantage. Because they are so small, they make less of an impact on phenomenon behavior measured. So the accuracy or the error which we get with the bigger size of sensors is totally reduced here. They require less power to function. Yes, of course, when we go with smaller, we get power consumption is reduced. Nanosensors have greater sensitivity because it is all nanoparticles there, so very sensitive. So hence we get more accuracy. Nanosensors have faster response, which enables possibility of real-time analysis. Since it is very minute, immediate response is there. So real-time analysis can be done easily when you go with nanosensors. The aforementioned benefits of nanosensors bring us new kinds of possibilities at nanoscale level. To name few, I'm telling this. Detecting airborne chemicals, chemical nanosensors able to monitoration of chemicals in the air. This could help detect dangerous chemicals or help measure the level of pollution in the air and inform scientists of how to react accordingly. So this is one usage application. Measuring temperature. Nanosensors allow us to measure the temperature of living cells and nanofluids using nano nanometers, measuring the temperature of living cell, which could reveal how particle at nanoscale level reacts compared to bulk materials. So that is a very good application which we use in many areas, like in medical or temperature measurement and things. So nanofluid heating up in electronics have become a problem, and nanosensors can help to detect this. And next will be your nano cooling further. So detecting virus. Scientists have developed a nanosensor that is able to detect if someone has a virus. It works by simply having the person breathe on the nanosensor. Because as we saw the comparison between nano and bacteria, the nanosensor can even immediately sense bacteria, a virus. So that is a very big advantage. So in olden days, normally what we used to do, they take blood, they put it for some process, then they take a microscope, they have to see, it is all manually. Here, using a nanosensor, immediately you can find whether virus is there or not. So nanosensors will then be able to inform the person of diseases that may have by checking the virus. We can immediately tell it. This is a breakthrough of medicine because it prevents the misdiagnosing of patients. Because normally this is one problem. Even when I go to some hospital or somewhere for some suddenly for blood check or something, they'll take a sample and keep. I used to think they took it and kept it in a bottle. If they replace the sticker or something, what will happen? Some problem will come. But when like these sensors are there, like a machine is with nano sensors where you can sit in front. If you breathe or even a nano injection can be done, they check the blood and give the result immediately, see the accuracy and see the time. Because nowadays when we go for many tests, they tell, sir, come after 2 days, we'll give you. But when this nanotechnology and things comes in, like it is going to be a very great time for medical stream also. Like the same everywhere, engineering stream also we require. Especially in medical, normally we know human are always concerned about their own health, and all engineers together we have to develop and give it. Doctors are there to save, but the technology which is coming up, which can give them a very good life. So there are some chances, like normally, like doctors, even engineers can help to survey people. So these are the fields where we have to be a little more concerned and work on. So this is so misdiagnosis, everything is not there, and quickly diagnosed and allowing treatment to start immediately. So nanosensors are important because they Hello, am I audible?
Yes, sir.
Okay. So we now are able to interact with and understand the particles at nanoscale better than ever before because of nanosensors. The nanosensors are opening doors to technology advancement, variety of topic helping to solve some of the problems on Earth at the moment. So a very upcoming area. So nanosensors, as like sensors, nanosensors, same. They use it in different applications. A few I have mentioned here. So smart office management, defense and military industry, consumer goods, environment, biomedical, agriculture, and all. So in MEMS, NIMS, robotics, mechatronics, everywhere now we go. Even in latest automobile cars, if you go to the top end cars, when you go with autonomous vehicle, the autonomous vehicle will be holding too many sensors. And for that, you have to spend too much design. So normally they go with nanosensors. Accuracy is also good. The vehicle, so that is the reason the importance of sensors are there. So yeah, humanoid, normally a robot, when it is structured like a man, we call it as humanoid. So there, if you check under the leg-like structure area, arms, everywhere they go with the nanosensors. So in each and every application nowadays, we go with nanosensors. So how it does, what all input you give to the nanoparticles, they sense it. With coupling of device, you get other output. So bacterial sensing, bacterial toxin, adulteration sensing, freshness sensing, brand protection, artificial smell taste sensing, everything can be done. So that is the reason this nanosensors are coming up in the field of engineering. So what is a nanosensor? Nano plus sensor added together, call it as nanosensor. Sensing action is done. Transducer is there, put electric signal, then detector. What is the change occurred? You can find it out. A nanosensor or nanoscale device that measures physical quantities and convert this to signal that can be detected and analyzed. So these are some pics of nanosensors. So flexible nanosensors, now they have started developing, which you can see they are holding 2 fingers. So here with a pin, they are showing a nanosensor. So the size you can compare. So this is the top right is your board type nanosensor. So different applications and different units like where they use. So a sensor, nanosensor is going to be such a small one. How nanosensor works? An analyte sensor, transducer, and detector are the components of sensor system with feedback from the detector to the sensor. The sensitivity, specificity, and ease of execution are the main goals in designing a sensor. So working, nanosensor work by converting the observed material or a process into electrical signals, which can be then analyzed on your need. Most nanosensors work by measuring electrical changes in the sensor material. So that is where the nanomaterial comes. Nanosensors detect changes from the external interactions and communication to the other nano components. So this changes in the material way, interaction way, nano components, the signals. So we get the output from the sensor. Nanosensor are like every other sensor you see in your daily life. Like regular sensors, nanosensors sense and detect different signals in a variety of environment. They can detect different signals including biomedical, electrical, optical, physical, and mechanical signals. So since even if it is nanoscale, nanosensor, just like our normal sensor, it has the wide application. So nanosensor history, as I told you, nanotechnology, father is scientist Richard. The history of nanosensors is also success story. Dr. Rolf Ulter, his research at IBM in Germany, the basic technology necessary batch processing of AFM cantilever probes. So he was working with AFM cantilever probes. In 1990, he also found this one company called Nanoprobe. After further path breaking developments, Nanoprobe became the first company worldwide to satisfy the emerging needs of high quality AFM sensors. So atomic force microscopy, scanning force microscopy. So these are some top microscopies which were brought by nanoprobes and nanotechnology. So he was the next person to implement a lot in practical way and a successful person in nanotechnology. Even if you Google immediately, you may get his name and Mr. Scientist Richard's name. So atomic force microscopy is a type of scanning probe microscopy, which demonstrate a resolution on order to fraction of nanometer, more than 1,000 times better than the optical diffraction limit. The information is gathered by feeling or touch the surface with a mechanical probe, a piezoelectric element that facilitate tiny but accurate and precise movement on electronic commanded enable precise scanning. So approximately it looks like this atomic force microscope, nano things. The next, some nano geometry, what are the different geometries of nanostructure? So bulk, cavity and probe, network and orders, planar surface, slit, structure surface. We have particles, shell, spheroid, periodical shell, rods, tubes. So these are some different geometric structures of nano, which are used in our nanosensors. So coming here, if nowadays everybody we use a mobile phone. So nanotechnology is playing a very big role in mobile phone. We know that how big was the mobile phone before some years and how slim and small is nowadays. So here, when I talk about mobile phones, even I feel what are the difficulties we face in certain things. Away from this, seeing here, the sensors everywhere. So here, everywhere, we have nanosensors. Proximity sensor, magnetometer, accelerometer, gyroscope, microphone, fingerprint sensor, thermometer, light sensor. So because everywhere nowadays in mobile, you can, even if you see the mobile, the screen opens, sensor based. After detecting your face, the mobile can be opened, sensor based. So everywhere it will be nanosensors. So you can see the accuracy in things, even if it is so small, it gives such a good accuracy. So when I was thinking about a mobile related to research, we have very big issue in this mobile phone. When we use it for a long time, especially when you connect a net, or when you talk for a long time, or when you miss taking it while charging, the mobile phone gets too hot. So cooling for the device, there also normally we have to go with nanotechnology. Even though if in all the mobiles there are some provisions nowadays, since they are giving waterproof mobile, okay, even you can dip the mobile in the water. So how come the cooling will take place? Should be material based or nano based. So where the technology has to be given. So when normally getting heat, first what thing we'll do, we'll switch off the mobile and keep it, put on a cool floor. Normally, if you are using the mobile in the car, if it is getting hot, I used to hold it near the AC duct. All new mobile phones are with high configuration. As we tell, can you, hello sir, can you mute? Hello. Hello. Maybe some dad is playing with a kid. So normally no problem, it happens. Yes, no problem. So keeping closer to the AC duct in the car. Normally I used to do when I'm traveling along. When we talk, if it get heat, suddenly sometime when your mobile is little 1 year old, or sometime you get heat transmission too much. And if your floor is cool, you put your mobile there. So here also the nano technology is to be implemented more. So because of the configuration. So here coming, nano cooling is also a very big field. Even if it is a nano device, nano chip, everything, any device which works for a particular time, there will be heat transfer. Since I think many of them are from mechanical engineering, any device which is working for a period of time, it generates heat. So the cooling system has to be done. So even there, in some electronic devices, to identify whether, because for us the mobile and things are okay, you take Google or a big software companies and everywhere. So here the components are working for 24/7 in a mobile phone. These deductions has to be taken with all you have as nanosensors and things. So here why I brought this is there's a lot of scope in materials and things, because normally when we talk about mobile, many students we encourage, or faculty normally in mechanical, we don't much think about mobile phone research and things. We think about app and things. But even you can take 2-3 old mobiles, check it out, and you can do some further research on that. So that is the reason I wanted to just share this. So the basic principle behind liquid cooling in smartphone works on the dissipation of heat. The cooling system consists of heat pipe with a liquid inside. This liquid becomes vapor by absorbing, just like our heat exchanger, but it will be a nano system. The heat is further dissipated and ambient to maintain the temperature. So there we come with nano electronics. So this sensor part, the nano sensor, as we told, whenever we talk about sensors, they much deal with the electronics. We know that. Here, normally, then the importance of electronics in this nanotechnology, we the people have much more scope than the electronic things which is happening there, based on material and design. So nano electronics refers to the use of nanotechnology in electronic components. The term covers the diverse set of devices and materials with the common characteristics that they are also small, that interatomic interactions and quantum mechanical properties need to be studied extensively. Use of nanosensors. Nanosensors are chemical or mechanical sensors that can be used to detect the presence of chemical species and nanoparticles, or monitor physical parameters such as temperature on nanoscale. So normally in olden days we would have studied about sensible heat, which cannot be entropy, enthalpy, and now it is about nanotemperature, which can be studied by using nanosensors. They also find use in medical diagnostic applications. Nanosensor. A nanosensor is a chemical or physical sensor constructed using nanoscale components, usually microscopic, submicroscopic in size. So they have different type. So basically, one is active and passive, which is classified. Active nanosensors. These are nanosensors that have ability to send signals which could be received remotely. Passive sensors. There are nanosensors that are really on observe of change in color, opacity, or fluorescence. So different types of nanosensors. I've just shown some pics here. So this is CNT, carbon nanotube, which is used there. So flexible, already we did it. It could also be a sensor that will detect the presence of nanomaterial or molecules in nanometer size range or small. So chemical phased water, electric current, everything mixed together you can manufacture. Types of nanosensors: optical, biological, chemical, and physical nanosensors are there. In optical nanosensors, proximity sensors, and ambient light nanosensors. In biological nanosensors, we have antibody, antigen interactions, DNA interactions, enzymatic interactions, and then chemical nanosensors, chemical compositions, molecular concentrations. Physical nanosensors, pressure, force, mass, displacement. These are the things. Is that sound disturbing? Actually, I think from my top floor, kid is playing there. Is it disturbing a lot or it's okay?
No, sir, it's not a problem.
Okay, okay. So coming to types, there are different types of nanosensors in the market and in development for various applications, most notably in defense, environmental, and the healthcare industries. The sensors share the same basic workflow, a selective binding of analytic signal generation from interaction of nanosensors with the bioelement or bioelement and the processing of signal into useful metrics. So example use of nanomaterials for different types of applications which are used in nanosensors much. So applications environmental and water, iron, polyethylene, carbon nanotube, graphene, in agrochemicals, silica and carriers, food packing, gold, nanocrystal, titanium oxide, silver, composite materials, graphene, carbon nanotubes. So these are the main materials nowadays we use in this nanosensors as a sensing material. So nanosensors types, carbon nanotubes based fluorescent nanosensors, quantum dot based on fluorescent nanosensors, DNA based on fluorescent nanosensors, peptide based on fluorescent nanosensors, plasmon coupling based on nanosensors, plasmonic enhancing and quenching, magnetic resonance imaging, photocatalyst, multimodal nanosensors. So coming into this properties of nanosensors, basic when we talk about, there are some of basic we have two, one is magnetic property and optical property. So coming under magnetic property, you have based on the ferromagnetism, ferromagnetism or antiferromagnetism. So based on that, the properties of that sensor works. So when you take a ferromagnetism, the order and the same magnitude without external magnetic field, be working on that. Disordered with external magnetic field, in the external magnetic field, the movements are ordered. In ferromagnetism, aligned oppositely with a different magnitude. So based on this magnetism and things, the sensor works. So aligned oppositely with the same magnitudes. So basically about optical sensors consist of nanoscale or nanostructured sensor materials, which shows a distinct reaction to electromagnetic excitation at optical frequencies. Excitance that optical frequency makes this optical sensors to change of optical properties can then be integrated into contact-free fashion from the macro world. Optical sensors, especially fluorescence, is commonly used optical chemical sensing technique. The inherent sensitivity of fluorescence analysis is well known, and because of this, it is often used for trace analysis. So owing to a small size of sensors, the sampling volume is reduced by more than 6 orders of magnitude over conventional sensors, making it ideal for subcellular measurements. So that is one main advantage in this. Example is nano biosensors for detection of nitric oxide via fluorescent detection, cytochrome C or fluorescently labeled cyclochrome C. Variant cyclochromes is which the hemo group is bounded by 2 cytons. Silent features of this is fast response and detection limit is 20 micrometer. However, how nanosensors are built? Most nanosensors work by measuring electrical changes in the sensor material. That is, here the material is nano material, so it has been called nanosensor. For example, if a molecule of nitrogen dioxide comes in contact with the chemical carbon tube, nanosensor, it will strip and an electron from the nanotube, that is the nanomaterial, which will make the nanotube less conductivity. So this change in this process gives us the variation of sensing. So once if it is heat or any whatever you want to sense, based on that we select whether mechanical based or optical based or something, and we mix it with, then the nano material is put into that, the nano sensor is there. So when that sensing is given to that, the change in this gives the output to us. So there are several ways proposed to make nanosensor, which includes top-down lithography, bottom-up assembly, and molecular self-assembly. So currently, to build nanosensors, there are two domains mainly used. So one is the top-down nanofabrication and the bottom-up nanofabrication. So in top-down, normally the bulk is converted into fragments as shown in the violet color. Then you get the nanoscale structure. So nanoparticles or nanofabrications. Bottom up, atoms are converted to clusters, and then you get the nanoscale structures. So these are the main two type where you fabricate the nano particles. Top-down approach, the physical top-down approach employs the use of photons, that is optical lithography, the electron beam lithography. So these two can be done, and an ion beam lithography. While the chemical top-down strategy relies essentially on chemical reaction that are brought about by chemical agents, example acid and base. And bottom-up assembly modeling is part-centric modeling method where the assembly design is started with principal structure of functional elements, and the individual parts are designed in relatively isolation from overall assembly. So molecular self-assembly. Molecular self-assembly is the assembly of molecules without guidance or management from an outside source. Self-assembly can occur spontaneously in nature. For example, in cells such as self-assembly of lipid bilayer membrane, it is usually result in an increase in internal organization of the system. So top-down nanofabrication, some examples are going template etching, selective de-alloying, anisotropic dissolution, thermal depositions. So nanosensors, basic classification, that is CNT nanotube. So carbon nanotubes are used. So drain source are there, charges. So when the force is acting on that particular area of the nano material, it gets the change in position and things. So the input is given in that form, and we can take the output. So even it is nano moments. That is the main thing here, not like a normal sensor. So according to even a very small change in temperature. Am I audible?
Yes, sir.
Okay.
Yes.
Okay. So CNT based FET transistors, physical.
Professor Babu, can we please wind up in 5 minutes and continue in the afternoon?
Okay, sir.
You can take another 5 minutes.
Okay.
Since you have two sessions,
okay.
we can continue at 2 p.m. again.
I'll close it at 12:45.
Sure, sir. Thank you.
Yeah, thank you. So here, if it is a gas molecule, we can go with chemical nanosensors, physical nanosensors, biological nanosensors. So depending upon the materials, nanosensors. So molecule self-assembly is a type of bottom-up approach in which molecules arrange themselves without any external guidance. Through molecule self-assembly, the structure that is wanted is programmed in the shape as well as in the functional group of the molecules. So when we go in nano, the thing is atomic, microscopic molecules. So these are all will be surrounding the sensors, which is even will act with the sensors. So based on the requirement which you have to sense, we have to consider those things also, and we have to design the sensor. So approach of nanotechnology, top down and bottom up. So 2 slides I'll complete it. Top down approach. This seeks to create smaller device by using larger ones to direct their assembly. Usually top down approach is used less than bottom up approach. Solid state silicon methods are used. They can create features small than 100 nanometer. So the device which in the picture you can see, this device transfers energy from nano thin layers of quantum well to nano crystal above them, causing the nanocrystal to emit visible light. Bottom up, assembling nanomaterial atom by atom or molecule by molecule, self-assembling. This approach is much cheaper. Things become much larger. Examples of molecule self-assembly are Western brick base preparing and nanolithography. So, so while manufacturing and designing a nanosensor, we consider this. So analytic, biorespirators, nanoparticles, transducers, and it gives the output. So in nanoparticles, depending upon your requirement and what is the sensor we need, depending on that you can decide, or cost wise or quality wise, so everything. So some examples which they have given here is the biorespirators, which is their tissues. You can use graphene oxide for bacteria. Can use quantum dot or upconversion nanoparticles. So there are a number of nanoparticles. Now, even now we require more nanoparticles. There is a lot of study which is going in nanoparticles, because when present condition, the cost of nanoparticles is a little expensive. Normally the people who do research in nano or nowadays, nanotechnology or any nano field, normally they buy aluminum oxide, I think, which is cheaper in cost. But when you check with aluminum oxide and things, we cannot use it in a very vast area for analysis. Flow stability and things are little difficult in that. So normally there are different nanoparticles. So lot of research is going in that. So please, you can also check with. So now from we'll end up the session. Afternoon we'll start with one video and we can go. Is it okay? Can I leave the session now?
Yes,
Hello?
Yes, sir.
Okay. So we have to meet at 2 o'clock.